Hi, welcome back. In this video, we are going to be looking at graphing exponential functions. But in order to graph an exponential function, we need to know what it is. So an exponential function is a function where the base is constant, but the exponent varies. So here is an example of our most basic exponential function. Y is equal to b to the x. In this case, b is a constant. It's a positive value, so it's greater than 0 and not equal to 1. So this is an exponential function. We're going to start kind of exploring this function, looking at the exponential function y is equal to 2 to the x. This is going to be about our most basic exponential function. So we're going to go through graphing it by using a table of values to kind of explore it. And these are some of the questions we're looking into as we are exploring this. So we're looking for any domain restrictions. Those are there any values of x that can't be? Range restrictions. This is any values of y that can't be. End behavior. What is happening at the extremes? And then any intercepts. So we're going to be looking at x and y intercepts here. So considering this function y equals 2 to the x, I want to start by finding what is y when x is equal to 0. So this is going to give me 2 to the 0, and if we remember, anything raised to the 0 is equal to 1. So I have the point 2, 1. And then I'm going to let's go in the positive direction first. So I'm going to look at 1. So that is 2 to the 1, which means I have 2 multiplied by itself 1 time, so that's going to be 2. If I plug in 3, this is 2 squared, which is 2 times 2, which is 4. If I plug in 3 for the exponent, this is 2 cubed, so that is 2 multiplied by itself 3 times, which is 8. So now I'm going to jump up a little bit, and let's go up to 10. So this is 2 to the 10th. This is 2 multiplied by itself 10 times. So let's kind of work through this. So that's 2 to the 1 is 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So 2 to the 10th is 1024. And then let's go all the way up to 100. That seems like a pretty big number. So this is going to be 2 times 2 times 2, 100 times. And I don't have 100 fingers, so I'm going to go to my calculator for this. And I get 1.27 times 10 to the 30. So this is a very big positive number. So this is a number that is huge. And what we notice is these are getting steadily bigger and bigger. So I am going to go all right, and then so I have 0, 1, which will be about here. I have 1, 2. I have 2, 4, 2, 3, 4. I have 3, 8. And by the time I get out to 10, I am at a huge number. So these are this isn't a line, this is kind of a curve. So now I want to go to the left and see what happens over here. So I'm going to start by plugging in -1. So this gives me 2 to the -1. And if we remember what a negative exponent does, a negative exponent flips whatever's in the numerator to the denominator and whatever's in the denominator to the numerator. So so I get 1/2. Okay, so now I'm going to plug in -2. So this is 2 to the -2. That means I'm going to have 1 over 2 squared, or 1/2 times 1/2, which is 1/4. If I plug in -3, I'll have 2 to the -3, which is 1 over 2 cubed, And we know 2 cubed is 8, so that is 1 over 8. So if I plug in negative 10, I have 2 to the negative 10, 1 over 2 to the 10, that is 1 over 1024. And if I plug in negative 100, I get 2 to the negative 100, which is 1 over 2 to the 100, which is 1 over a positive big number. And if I take 1 over 2 raised to the 100, or 2 raised to the negative 100, I get 7.9 times 10 to the negative 31. So what this means is that this is a very small number, but it is a very small positive number. I'm only taking positive numbers and multiplying them by them, multiplying positive numbers by each other. The only way to get 0 through multiplication is to multiply by 0. And I'm just multiplying by 1/2 a bunch of times. So this ends up being a very small positive number. And by very small, this is approximately 0, but just a little bit positive. So if I graph this, I have negative 1 1/2. I have negative 2 1/4, negative 3 1/8, and we are getting we're getting much and much closer to 0 as we go to the left, but we are not ever going to equal 0, and we are not ever going to cross that axis of x equals 0. So we are going to end up with what we call an asymptote at y is equal to 0. An asymptote is a line which the graph approaches but does not cross. Because exponents are just how many times should I multiply 2 by itself or divide 2 by itself, an asymptote of y equals 0 means that this is never going to equal 0. This cannot be equal to 0. And beyond that, this will always be a positive number. So for domain restrictions, there are none. Our domain here is going to be from negative infinity to positive infinity. We can plug in any value of x we want. In terms of our range restrictions, our function 2 to the x has to be positive. It can't be less than or equal to 0. So for our range, it is going to be a soft bracket 0 to positive infinity. The x-intercept we have is at 0, 1, and there is no y-intercept. But let's think about our end behavior here. As x approaches positive infinity, so as x gets bigger as we go in this direction, our y value is going to approach positive infinity. It's getting huge at a rapid rate. As x approaches negative infinity, so as we go this direction, as x gets more and more negative, this quantity is going to get smaller and smaller. It's actually going to approach 0, but it's always going to stay positive. So I write this as 0 with a little plus sign over here. This means that y will approach 0 but stay positive.